Welcome back to class, my amazing student. In this class, we shall discuss polynomials 2, and the lesson outline for the topic are zeros of polynomial, the remainders theorem, roots of cubic equations. Now let's begin with zeros of polynomials. The general polynomial takes the form p of x is equal to a subscript n x raised power n plus a subscript n minus 1 x raised power n minus 1 till we have a subscript 2 x raised power 2 plus a subscript 1 x raised power 1 plus a subscript 0, where the values of x for which p of x is equal to 0 are called the zeros of polynomial. Example 1. Find the zeros of the polynomial a p1 of x is equal to x squared minus 5x plus 6, and the second question b p2 of x is equal to x squared minus 1. Solution to the first question. P1 of x is equal to 0. That is zeros of polynomials. P1 of x is equal to x squared minus 5x plus 6, and that is equal to 0. So this polynomial is a quadratic equation, and to solve this equation, to factorize and look for the values of x, you look for two numbers that you multiply together to get 6, and when you add together it gives minus 5. And what are those numbers? Minus 3 and minus 2. And that's the reason why the values of x there are 3 or 2. Hence the zeros of p of x is equal to what? 3 and 2. The second question. P2 of x is equal to 0. And don't forget that P2 of x is equal to x squared minus 1. And that's the reason why x squared minus 1 is equal to 0. X squared minus 1 are difference of 2 squared. And that's the reason why it gives us x minus 1 and x plus 1. And the final answer to this question is 1 or minus 1. The values or the zeros of p2 of x is equal to minus 1 and 1. The remainders theorem. The long division method enables us to find the quotient and remainder of any given polynomial. Q of x is the quotient, r or r of x is the remainder, d of x is the divisor, and p of x is polynomial or dividend. This is a relationship between the polynomials, the quotient, the divisor, and the remainder. P of x is equal to q of x dot d of x, that is multiplied by d of x plus r of x. When a polynomial is divided by the divisor, then we obtain q of x plus r of x all over d of x. For example, determine the quotient and the remainder when 2x raised power 4 minus 3x raised power 3 plus x squared minus 4x plus 5 is divided by x squared plus 3x plus 1. Solution. Now, using long division method, we can identify the p of x there, the divisor, d of x, the quotient, and the remainder. Now, the polynomial is 2x raised power 4 minus 3x raised power 3 plus x squared minus 4x plus 5. And the divisor is x squared plus 3x plus 1. Now, each of the term in the divisor is going to divide the term in the polynomial. And the first term is x squared in 2x raised power 4. That gives us 2x raised power 2. Then 2x raised to power 2 is going to multiply all the terms in the divisor. And that is x squared plus 3x plus 1. Then 2x multiplied by x squared. That gives us minus 2x raised to power 4. 2x multiplied by 3x plus 3x. That gives us plus 6x cubed plus 2x multiplied by plus 1. That gives us 2x raised to power 2. Then we bring the remaining terms under the polynomials down. We have minus 4x plus 5. We bring it down. Now, the result there now is minus 9x raised to 3 minus x squared minus 4x plus 5. Now, this is the current polynomial we are going to use. And the divisor still remains x raised to 2 plus 3x plus 1. Now, x raised to power 2 in minus 9x raised to 3 gives us minus 9x. Now, minus 9x in the quotient is going to multiply all the terms under the divisor. And that is minus 9x multiplied by x squared. That gives us minus 9x cubed. Minus 9x multiplied by 3x. That gives us minus 27x squared. Minus 9x multiplied by 1. That gives us minus 9x. Now, when we introduce negative sign again, minus 9x will cancel out. Now, minus times minus 27x squared gives us plus 27x squared. And minus x squared plus 27x squared gives us 26x squared. Minus times minus 9x gives us plus 9x. This time around, minus 4x plus 9x gives us plus 5x. Then we bring the last term under that polynomial down. It becomes plus 5. Now, the current polynomial we have now is 26x squared plus 5x plus 5. Now, and the divisor still remains x squared plus 3x plus 1. I will repeat the same process till we have the remainder. 3. Find the remainder. Suppose f of x is equal to 2x raised to power 3 minus 3x squared plus 4x minus 1 is divided by x minus 1. To determine the remainder, we consider two methods. Method 1. Method 1 is long division method. Now we can identify our quotient, the divisor, the dividend or the polynomial, and the remainder. Now, x minus 1 is dividing 2x raised to power 3 minus 3x raised to power 2 plus 4x minus 1. Now, x into x raised to power 3, that gives us 2x raised to power 2. 2x raised to power 2 in the quotient is now going to multiply all the elements or the terms in the divisor, and that is x minus 1. So 2x squared multiplied by x, that gives us 2x raised to power 3. 2x squared again multiplied by minus 1, that gives us minus 2x raised to power 2. Now, when we introduce negative sign, 2x raised to power 3 minus 2x raised to power 3 will go out. Now, minus in the outside multiplied by minus 2x squared, that gives us plus 2x squared. Now, minus 3x raised to power 2 plus 2x squared is going to give us minus x raised to power 2. Now, bring the other terms in the polynomial, bring them down, and that is plus 4x minus 1. Now, the polynomial this time around is x squared plus 4x minus 1, and the divisor still remains x minus 1. When this divides the polynomial, x in x square, that gives us minus x, and that is the minus x that appear in the quotient. Now minus x in the quotient is going to multiply the divisor again. Minus x multiplied by x, that gives us minus x square. Minus x multiplied by minus 1, it gives us plus x. Now we introduce negative sign again and repeat the same process, method 2. Now in method 2, we are going to equate divisor to be equal to 0. And in this question, the divisor is x minus 1. Then x minus 1 is equal to 0, therefore x is equal to 1. To get the remainder is the same thing as f of 1, because the polynomial f of x is equal to 2x raised to 3 minus 3x squared plus 4x minus 1. And to get f of 1 is going to be substitution of 1 into anywhere we see x in f of x. And that is 2 into 1 all raised to 3 minus 3 into 1 raised to 2 plus 4 into 1 minus 1. And f of 1 will now be 2 minus 3 plus 4 minus 1. Therefore, the remainder is 2. The roots of cubic equation. The general cubic equation can be written as ax raised to 3 plus bx squared plus cx plus d is equal to 0, where a is not equal to 0. Thus, if alpha, beta, and gamma are roots of the cubic equation, ax raised to 3 plus bx squared plus cx plus d is equal to 0, where a is not equal to 0, then alpha plus beta plus gamma is equal to minus b over a. Alpha beta plus alpha gamma plus beta gamma is equal to c over a. Alpha beta gamma is equal to minus d over a. Example 4. One of the root of the cubic equation ax raised to 3 minus 9x squared plus 26x minus 24 is equal to 3 is 3. And one of the other two roots is twice the other. Find the other two roots. Solution. Let alpha be one of the other two roots, and then 2a is the other root. In x raised to 3 minus 9x squared plus 26x minus 424 is equal to 0, the coefficient of x cubed there is a, and that is 1. The coefficient of x squared is equal to b, and that is minus 9. The coefficient of x is 26 and c is 26, while d is minus 24. The three roots of this equation are 3 alpha and 2 alpha. Recall that the sum of the roots of the cubic equation is equal to minus b over a. Therefore, addition of all these roots, alpha plus 2 alpha plus 3 is equal to minus b over a, and that is minus 9 all over 1, which gives us 9. So therefore it means alpha plus 2 alpha, that is 3 alpha. So 3 alpha plus 3 is equal to 9. 3 alpha is equal to 9 minus 3, which is 6. Making alpha the subject of the formula, you have alpha is equal to 6 over 3, and alpha is therefore 2. Since we are looking for twice of alpha as one of the roots, so 2 times alpha is 2 times 2, which gives us 4, which means that the roots are 2, 4, and 3. Thank you for listening.